Today's lesson is on section 5.1, right linear equations in slope-intercept form. We just got done with chapter 4, and in chapter 4, a lot of times we took some information, either an equation or ordered pairs or intercepts, and made some kind of graph. In chapter 5, a lot of what we do is we take information and make some kind of equation. So sometimes just going backwards from things we used to do. The most important form of the equation we need to know is the one we've already learned, slope-intercept form. Sometimes in this chapter, what we're going to do is we're going to take information and make an equation. In the past, we took slope-intercept form, some equation, and then made a graph, or maybe made a table, or found some information from that. In this chapter, they're going to give us the information, and we're going to make the equation. Again, remember, the nice thing about making an equation in slope-intercept form is there's just two key pieces of information you need to know: the slope and the y-intercept, as it says right in the name, slope-intercept form. So often, if you can find these two things, you can make an equation in slope-intercept form. Here's a problem that we used to run into in chapter 4. Or again, they'd give us the equation, we'd pick out the key information and then use that to make a graph. Like this one says, identify the slope and y-intercept. We did stuff just like this in I think the first section in chapter 4. So the slope of this equation you'd say is -4, and you'd say the y-intercept is 10. Positive 10. So that'd be me identifying the slope and y-intercept of that equation. Well, in this chapter, what they might do instead, or what they will do instead, is things like this. They're going to give us m is -4, b is 10, and they want us to make an equation given the slope and the y-intercept. Could you write an equation knowing the slope of the line that we're looking at is -4 and the y-intercept is 10? Well, again, given slope-intercept form, we should be able to. The only things we need to make an equation in slope-intercept form are the slope and the y-intercept, as I mentioned before. And we have those two things. Here's the slope, here's the y-intercept. So if I want to make some equation of this line, knowing the two important pieces of information there that I know, I could say, well, the slope is -4, so it'd be like y equals -4x. And the y-intercept is positive 10, so it'd be like plus 10. So there would be the equation. Again, in chapter 4, we took an equation like this and maybe identified those things, and then use it to make a graph. Well, in this case now, they're giving us those key pieces of information, and we can make the equation. So as I have at the top there, it's kind of like working backwards from what we used to do. This first problem here, I'm going through a couple examples here. This first one says the slope of some line is -2 and the y-intercept is 5. Again, here's slope-intercept form, y equals mx plus b, one we should be getting more and more familiar with. Well, the slope is -2, so I'm just going to put y equals -2x, and the y-intercept is 5. So I'm just going to put plus 5, and there's an equation that would model a slope of -2 and a y-intercept of 5 being a linear equation. This next one, the slope is -3/4, the y-intercept is -4. So if I was going to make an equation for this, I'd say y equals -3/4x minus 4, because the y-intercept is -4. So again, a way to write that or incorporate that in the equation is to write subtraction. So -4. This third one, slope is -5/9, the y-intercept is 50,001. Again, just to kind of prove to you, it doesn't matter what the numbers are, as long as I know where to plug them in, making this equation is not too bad. The slope is -5/9, so -5/9x plus 50,001. That would be my equation given that information. Again, also in chapter 4, sometimes we got an equation and made a graph of it. So in chapter 5, when we're making equations, it makes sense that maybe they'll give us a graph and we have to go backwards and make the equation. Well, given this graph right here in front of me, I have 2 points on it as well, and a line that goes to those 2 points. The point A, which is 0, -4, point B, which is 2, 2, and it says write an equation of the line shown. Well, again, y equals mx plus b. If I can just find out what the slope of this line is and the y-intercept of this line is, then I can plug those two things in and make the equation. So what's the slope of this equation? Remember, there's 2 ways I can do it knowing these 2 points on the line. I could either subtract the y-coordinates and say, oh, 2 minus -4 and 2 minus 0 and put that in a fraction. I'll even show that way. 2 minus -4 will be on top of my fraction. 2 minus 0 will be on the bottom. The y-coordinates, when I subtract those go on the top, because remember the y changes on the top of my slope. The change in the x direction is on the bottom of my slope. If I chop here, this ends up being 2 plus 4, which gives me 6 on the top. 2 minus 0 gives me 2 on the bottom. and 6 over 2 is just 3. So I could say the slope of this line would be 3. Again, the other way you can see this too is, remember, if I just look at a graph, if they give me the graph of some problem, some equation, then I can just go up and over so much. Slope, we talk about this fraction, rise over run. Between 2 points, how much do I go up and over on a line is the ratio that the line's increasing. And so if I can just pick out 2 points like A and B in this case, I can go up so much, over so much, and if I can count those spots, I can figure out what the slope is too by knowing the rise over the run. The rise looks to be 1, 2, 3, 4, 5, 6. The run, I go to the right 2, so 6 over 2, again, just like what I had over here. And if I do 6 over 2, I also get 3. So again, just showing you could do it either way. Both should give you the exact same answer. So, but knowing that I can subtract the coordinates, or I can just kind of, if I have the graph, I can just kind of count up and over. What's the y-intercept of this line? Then again, I need the 2 key pieces of information. I need the slope, I need the y-intercept. I've got the slope right here. The y-intercept, again, is just where the line crosses the y-axis. Here's the line, and here's the y-axis. So where's that point? Well, it happens to be point A in this case, so I have that point. So if it's 0, -4, I'd say the y-intercept is -4, because I went down 4 from the origin. That's where the line crosses the y-axis. If I'm going to make an equation for this line, the slope is 3, so I'd write y equals 3x, and the y-intercept's -4, so I'm going to write -4. Going through just a few examples to make sure we got the idea. Again, I'm going to make an equation in slope-intercept form. So that means I need those 2 key pieces of information, the slope and the y-intercept. If I can figure those 2 out, then I can make an equation of each of these graphs, or the equation that models each of these graphs. So I need M, and I need B. Just like we've done in the past, except now we've got the graph, and we got to figure out what the slope is and what the y-intercept is. And even find the slope, we've done this in the past too, where I give the students a line, and they find the slope of it knowing the 2 points on the line. So even this, not brand new information, we're just using it in a new way. If I look at this graph, again, I'm going to count the rise over the run. I'm going to see how far do I go up and over between each of the points for this first one. So if I look at it here, here's a point, 0, -3, and 4, -2. They give me these 2 points. It looks like I go up 1 spot and over 4. So I'd say the slope of this line would be 1/4. If I'm looking for the y-intercept, it happens to be just this first point, 0, -3, so I'd say b is -3. So if I'm making an equation for this line, I'm going to say y equals 1/4 x minus 3. For number 6, this one I'll do the subtracting of the coordinates, just to show that, again, you can find the slope either way, it does not matter. So one way to find the slope of a line, if you know 2 points on it, is just by subtracting the y-coordinates, and then subtracting the x-coordinates, and putting that in a fraction. 5 minus 2 over -4 minus 0. 5 minus 2 is 3. -4 minus 0 just gives me -4, so I would just say that the slope is -3 over 4. And again, that should make sense. Look at the line. The line is a negative type slope line. It's going down to the right. So it makes sense that my fraction then is a negative number, a negative fraction, like -3 over 4. As long as one of those numbers is negative, I can say it's a negative fraction. So it's a negative slope. And my y-intercept, again, in this case it's right on the grid, it is 2. So my y-intercept is 2. So if I'm going to make this equation, I know the 2 key pieces of information there. Y equals -3/4 x plus 2. Last one here, and it's slightly covered up though, so I'm going to uncover one of the points. I've got 2 points on this line. I'm going to try to make an equation of this line in slope-intercept form. So I just need to find them, the slope and the y-intercept. To make an equation in slope-intercept form, I need the slope and the y-intercept, those 2 things. The slope of this line, this one again, I'll just kind of count up and over. I'll use the rise over the run. It looks like I go up 5 spots and over 5 spots. So 5 over 5 would give me a slope of just 1. So if I reduce that fraction, 5 divided by 5 is 1, so that's my slope. My y-intercept Well, the y-intercept is the line, it's right where it crosses the y-axis, which is right at the origin there, 0, 0. So in this case, I'd say the y-intercept is 0. So this equation, y equals, well, the slope is 1, so I could write 1x plus 0, but realize I don't have to write plus 0 for anything, so I don't need really that on the equation. And also, if I put 1x, I can leave it like that, but remember, we don't need to write that 1 in front of a variable, so really I could just put y equals x. It's just the parent function, so either of those answers is right. Y equals 1x, or you can just write y equals x. So again, in this chapter, at least the start of this chapter, chapter 5, what we start off by doing is we're going to make the equation. They give us information, like the slope or the y-intercept, or they give us some graph. We have to find those two things. And once we find them, then we can make our equation, again, going backwards from what we did in previous chapters.